Okay. Right, let's have a look. We'll need the calculator now for these. Let me get my pen. You know, I'll be honest with you, I think the hardest thing about being Muslim is the no pork. That'd be the hardest thing for me. I don't think I couldn't cope with that. It would be too difficult, I'm sorry. It's just not possible. I could probably manage with the no alcohol. I think I'd be okay with that, but the no pork, I could not cope with that.
No pork is okay for me, but
is it?
But no alcohol.
No, okay.
That's
So
crazy.
together, yeah, wouldn't be good for us. Okay, one electron orbits one proton. Okay, so one electron orbits one proton. Okie dokie. Part 1. Now, what atom is this? Which atom is this from chemistry? One electron around one proton. Hydrogen atom, isn't it? Yeah? Okay. So, question A. What is the electric field strength caused by the proton? So, do you remember that's the formula 1 over 4 pi epsilon 0 Q over R squared. Yeah? Now, let's put that in on the calculator. Oh, rats, I have to open the calculator again, sorry. Well, maybe one of you has calculated this already.
1.44 times
Newtons per coulomb. Did you get the same thing, Siva? Nice, okay. Right, the next one. Positive 11. What is the force experienced by the electron? Okay, so force formula is QE, yeah? So if you just take your answer here and multiply it by Q, maybe you already have this calculated, but what did you get?
2.31 times 10 to the power of 10
Newtons. Good job, guys, okay. Next, what's the acceleration? Okay, so the acceleration is F over m. So now, which mass do you divide by? It's the electron. So if you divide by the electron's mass here, what answer do you get? Did you do something different? What did you do? Okay.
2.54 times 10 to the power of 22.
Times 22 meters per second. Yeah?
Oh, no, I did it right.
Oh, well then believe in yourself. Yeah. You erased it and you did it right. Oh dear.
I erased the question after it.
Now, did anybody have any luck with part D, the periodic time? You got it, Siva?
That's the one I just erased.
All right. T equals 2 pi over omega. Yeah? But omega equals, oh, hang on, sorry, let me think here. Sorry, yeah, but omega equals v over r, and you also have the formula that acceleration is v squared over r from circular motion. So I can say omega is square root a r, that's the v, over r. So that's root a over r. So the t is 2 pi root r over a. And we know the r and the a, so we can work out the t. So let's type that in. 2 pi root a, which we just got, is 2.54 times 10 to the power of 2 2 pi root fraction 2 times 2.54 times 10 to the power 22 over, oh rats, I did it upside down. 2.54. What answer did you get, Matt? Or Siva, if you can.
1.55.
I might be wrong, but I think I'm right. 3.94 times 10 to the minus 16. Continue. Continue. Yeah. E. What's the electric field strength caused by the electron? Well, it's the exact same formula, and not only is it the same formula, all the numbers are the same. So this is the same answer that you got as part A. Same as A. F is different. The acceleration is the force over the mass, but it's a different mass now. So it should be about the same, but 2,000 times smaller. So F over M. About 1.38 times 10 to the 19? Okay. Yeah, 1.38 times 10 to the 19. Okay. Oh wait, sorry, I skipped the part. Sorry. That's G. F is the same as B. Sorry about that. That's G. That's F. Okay. How did that part go? Good, bad? Siba, you got some of these right, yeah? Where did it break down? D. Yeah, the time. Kim, how did these go for you?
I went to last time.
Oh, yeah. You weren't here. I forget why. Were you sick? Oh, yeah, it was morning class. Yeah. In Cav. That's right, I remember now. And I said at the time, where's Kim? She's probably in her bed, asleep, yes. I remember. Okay, continue. Yep. Two horizontal plates are a distance 10 centimeters apart, and there's 1 kilovoltage between them. And I want to know what charge do we need here so that this 0.001 kilogram mass doesn't move. Okay, so look, if you look at this particle, there are two forces on it. The field pulling it back up and the weight pulling it down. How big is the weight? That's 0.001 G. And how big is this force? This force is equal to QE, which is equal to QV over D, which is equal to Q1000 over 0.1, which is equal to 10,000 Q. So that should equal that. So that should equal 10,000 Q. So I have my answer now. The Q will be 0.001 G over 10,000. So yeah, if you can get that, Siva, that'd be great. minus 7. So that's 981 nano, 981 nanocoulombs. Okay. This is Connell's reply. Loading. Okay, do you write that down? Yeah? I can scroll down. Number 3 is a hard one. Hard one. So, can you see the picture there? Oh, here's his reply. He said the Septembers have assignment due on Wednesday. I wouldn't mind having them for an hour. There's no course leaders meeting, so I could schedule class for 2, which will free them up. So O'Connell's suggesting he takes you from 2 o'clock to 3 o'clock tomorrow, and then you're free after that. Will I tell him yes or no to that? So you'll see him instead at 2 o'clock. Okay. They said that's great. Well, he didn't quite say that's great. Right, let's have a look at this last one here. Did anybody get to try it? No. Did you look at it and say, no thank you? No thank you, Stephen. You can keep your question 3. So you have a chimney stack, like in the picture here. And 2 vertical plates, they're a distance of 30 centimetres apart. 30 centimetres, okay? And they're under a potential difference. The plates, so this is 10 metres. Now what's happening here is you have some smoke which is rising up the chimney. And the smoke moves up with a speed of 0.5 metre per second, okay? Now, you can think of the smoke as being made up of these little dust particles. And each of these little particles, they have a mass of 10 to the minus 5 kilograms, and they have a charge of 10 to the minus 10 coulombs. By the way, this is actually, this is a real thing that they do. So what happens here is, as the smoke rises up the chimney, it has a positive charge. So what will happen to it if it has a positive charge? It will be pulled towards the negative plate. So what happens is the dirt in the smoke, the real black stuff in the smoke, it will stick to the plate. So the smoke that comes out is a little cleaner. Do you understand? Like some of the black dirt in the smoke has been pulled out of the smoke, because the black dirt, it has a positive charge, so you can actually pull it out. Yeah. So then at the end of the day, what happens is there's a little, it's a little hammer, and the hammer hits the plate, so it goes, and then all the dirt that collected on the plate falls down into a tray. So you remove some of the dirt from the air, you can collect it up, and then maybe you can recycle it or you can do something with it. So the question is, we need to know what voltage to use so we can capture all the dirt. Okay? So, in the worst possibility, the worst case, is the particle starts here at the far left and just about gets caught before it leaves. That's like the worst possibility. The best possibility is that the particle starts here and immediately hits the plate. So which one should we do the calculation for? The worst one. Because we need to make sure that even in the worst situation, we can still capture it. That's the idea here. Does that make sense so far? I can't tell from your faces. Is that yes? Okay. You're not very convincing, but okay. Right, continuing. So, how much time do we have to capture it? So the time to capture, how long will it take the smoke to reach the top? You have all the numbers there. What would it be? How much time would it take? 10 divided by 0.5, which is? So we have 20 seconds to capture the dirt before it escapes. Okay? Right. So if you look at the problem horizontally, U, V, A, T, S. Now horizontally, okay? What's the U? 0. Horizontally. It only has vertical, okay? What's the V? We don't know. What's the A? We don't know. The T we do know. We have 20 seconds to capture it. And the S, we know the S. What is it? No. Horizontally. 0.3. Do you understand? So as it's moving up, we need to make sure that it travels horizontally 30 centimeters. Because what will happen if it travels 30 centimeters horizontally? It must hit the plate. Right? It must. Because the plate is only 30 centimeters wide. Okay. Right, so what we'll do is we'll calculate the A. I'll give you 1 minute. Calculate the A for me. You have enough information here. I want the A. Got the A for me? Who are you chit-chatting to? You don't know these formulas? They're not burnt into your brain? Which formula do we need, Ken? Oh, don't make teacher sad. He's very tired. He doesn't want to be sad and tired. Yeah, but which formula to use to get the A? Yeah. Yeah. Siba?
Yeah.
S equals UT plus a half AT squared?
Yeah.
You agree? Wonderful. So, if you use this formula, Matt, what did you get for your A? (1.5 times 10 to the minus 3, is it? Okay. Now watch carefully, please, because now we're going to calculate the voltage. So we know, Newton said that F equals MA. And we know the M and we know the A, so we can know the F. Yeah? So that's equal to 10 to the minus 10 times 1.5 times 10 to the minus 3. So that's 1.5 times 10 to the minus 13? Huh? I thought that, oh sorry, thank you, sorry. 10 to the minus 5, not 10, sorry, 5. So that's 8 there, isn't it? However, we also know that F equals QE, and E equals V over D. So we can say that F equals Q V over D. So we can solve this to get the V. The V will be 1.5 times 10 to the minus 8 times 0.3 over 10 to the minus 10. So that would be, let me see, I don't think I need a calculator, I can do this. 0.45 times 10 to the 2, so that's 45 volts is what the voltage needs to be to capture all the dirt. Yeah? Now, I have bad news for you. That was an exam question. That was a section B question a few years ago. So, the fields, it's tricky. It's tricky. Did the solution make sense, though? Yeah. The last one here is the picture. So if everyone can look at the 4 pictures and tell me what they think. So the first picture, what do you think it is on the left and the right? I think it's positive, positive. Yeah? Would you say so? Siva? Yeah? The 4 pictures? What about the next picture, the top right? The top right. So what would we say that is? Negative, negative. Okay, bottom left? Positive, negative. And bottom right? Positive, negative. Is that what I had at the back? Positive, positive, negative, negative, positive, negative. Positive. Huh? The last 2 are the same? Oh, sorry, but I think the difference is in the last 2, I think in the bottom left picture, the negative charge is supposed to be a stronger one because you can see there's more of the field lines. And you see in the next picture, the positive charge is a bit stronger, I think. I'm not sure why I did that. Maybe you should ignore it. I don't know why I have the last one twice. Why do I have the last one twice? I don't know. I can't remember my reason. Maybe I didn't have a reason. Alright. So yeah, these are hard. These are hard. You need to be practicing them. So for the next lesson, we've got a few minutes left. I really, really, really would love if you had some of these done before you go home for sure. Which one? In the next page, how many have you done, Siva, for example? You're on number 4?
I'm on number 5.
Oh, great. Kim? Which one are you doing on the next page?
What?
You're on 4 or you finished 4? Which question are you doing on the next page?
3 and 4.
Okay. Again, the bad news is even question 6 is something that was on the exam. Yeah, so these are hard questions, okay? Could you just use the last few minutes, about 10 minutes, to try and get most of these finished and then finish them at home, okay? And if you need a little help, I can help you. Yeah, which one? Yeah, about this one? Okay, well let me just, what, should I write it here or should I close it? It's about this one?
No, not this one.
The which one?
The time period.
The which one?
Time period.
Oh, did I make a mistake?
No, I know.
Well, I can close this? Yeah, okay.